It's Miss Best from Best Online Tutoring. I wanted to do a quick review of graphing polynomials. This is actually a lot of information, so I'm going to go a little bit fast. So you may want to watch the video multiple times if you want to figure out the steps. This is for students who are in Algebra 2 and Pre-Calculus. So as a reminder, this is a polynomial in standard form, and we can look and see that it has a degree of 4 because the highest exponent is 4, and it is written in standard form because we're going from the highest exponent down to the lowest exponent, the constant. So can we graph it from this form? Yes. If you don't have a calculator, so this is for students whose teachers will expect them to be able to graph without a calculator, you can graph from this form. You can graph any function by making a table. But I want to look at graphing from the intercept form. And the intercept form would be when I would take this and I would factor it, and I'm going to get these factors. So we are going to look at graphing the polynomial from the factor form because you get a lot more information and it's a lot easier to graph from this form versus the standard form. Can you do the standard form? Yes, it just takes longer. It's easier to graph it from intercept form. Okay, what are we going to look for first? We're going to look at the degree because the degree is going to tell us the shape of the graph. If we have an odd degree, so you can see here I have different polynomials. Here we have degree 1, and we see that's a linear. You're used to seeing that y is equal to x. So the degree is 1. Odd, we get a straight line, and it goes down towards negative infinity and going towards positive infinity on the right side. Same behavior with a cubic. A cubic is odd. Same thing. It's going down towards negative infinity, and when we're in the negative side of the graph of the x-axis, and when we're on the positive side, it goes toward positive infinity. And the same thing with degree 5. So when it is odd, you can see that the behavior basically is different at the starting point versus the end point. Let's look at even. You've seen quadratics. We did that at the beginning of the school year. So degree 2, we see that they both go up. So whether we're going towards negative x or towards positive x, the graph goes towards positive y. Okay, so it has the same end behavior when it has an even degree. 2 and 4, same thing. They both go up. Let's look at the turning point. So the turning point is how many times does the graph turn? Okay, these would be the minimums of the graph or the maximums depending on the direction of the graph. So here we have 2, but we only have 1 turning point. So there's a formula that we can use to figure out the turning point. And the turning point is useful when you're graphing. So the formula is n minus 1. I use TP for turning point. So n is the degree. So whatever the degree is, subtract 1. That's how many times your graph will turn. Okay, and that it will be the maximum. It could be less, but that will be the maximum times that your graph will turn. So let's try it again. 3, right? We can see here we have a turning point here and a turning point here. So we have 2 turning points. 3 minus 1 is 2. So that's just like we would predict from the formula. Degree 4, we have 1, 2, 3. So every time the graph changes direction, that's a turning point. So 4 minus 1 is equal to 3. So we have 3 turning points. So the degree tells you a lot of information. It tells you the end behavior. It tells you how many turning points the graph will have. And it also tells you the maximum number of zeros that your graph will have. Okay, and again, you can have less, but you can't have more. Okay, let's look at some other things that we can predict. So we just talked about that the degree will tell us the end behavior, but also the leading coefficient helps determine the end behavior as well. If the leading coefficient is positive and the degree is even, we can see that the graph will go up. And this is how we describe the end behavior. As x goes to negative infinity, f of x or y goes to positive infinity. As x goes to positive infinity, so this direction, f of x goes to positive infinity. This is how you need to memorize this. It's in the textbook, and I'm sure your teachers have given it to you in your notes, but I've seen that on tests that teachers do expect that you write it in this format. Okay, now if there's a negative a, right, we know that this is going to be a reflection. So it just flips down. Instead of going to positive infinity, it's going to go to negative infinity. So as x goes to negative infinity, f of x goes to negative infinity. As x goes to positive infinity, f of x goes to negative infinity. And if it has an odd behavior, as we mentioned, it will have a different behavior in the negative infinity versus when you're going towards positive infinity. So if the leading coefficient is positive, as x goes to negative infinity, you can see the y will also go to negative infinity. As x goes to positive infinity, the y also goes to positive infinity. But if we put a negative in front, it flips it, it reflects it, and the behavior changes. So as x goes to negative infinity, y goes to positive. It's flipped. As x goes to positive, y or f of x goes to negative. So the leading coefficient and the degree will tell you the end behavior and will tell you the number of times the graph will turn, and will give you an approximation of the number of zeros. When we're in intercepts, we can actually calculate those zeros very easily. And we did this again with the quadratics. That's why we always study quadratics first, because they are the easiest polynomial to work with when we're talking about graphing. So here we have x plus 2. Remember, we just take each one and make it equal to 0 to get our zeros. That's why they're called zeros, or our roots. So we get x is negative 2, and then we're going to have x is positive 1, and then we will have x is negative 3. Okay, so we can quickly see what the zeros are from the intercept. That's why we like the factor form. It's very easy to determine the roots or the zeros. Lastly, we'll look at the multiplicity, and the multiplicity will be if that root or zero is occurs more than once. So you will look at the exponent inside of the factor form. And one thing, when we're graphing it, if it only has one root, that's called multiplicity, a single multiplicity. We call this a slice. So when I see that it only occurs once, I'm going to say, oh, it's going to slice and go through the x-axis. So call that a slice. These are just like quick things to help you remember how to graph it. If it's even 2, 4, 6, then it's going to bounce at that 0. Basically, it repeats itself. So it's going to bounce. Okay, so whenever you see an even multiplicity, just think and know that your graph is going to have a bounce. And then if it's 3, 5, 7, so an odd number that's greater than 1, it's going to sort of wiggle. Okay, so it's not a straight slice. It's going to behave like how a cubic behaves, and it wiggles across. So a lot of teachers will call that a wiggle. So it's just helpful to remember this when you are graphing. So quickly, we're going to write the equation. So we're going to look at this graph, and using those properties that we just talked about, determine what the equation of this graph could be. Okay, so this is just a quick overview of this. Oh, let me get my pen here. Okay, so first I'm going to say, well, what would the degree be? So looking at this, number one, I know that the degree is odd because I see that they have different behavior at the beginning and the end. So I know it's an odd degree. So I'm going to count how many times does this polynomial turn. So it turns once and it turns twice. We're going to assume that these are the only turns that it has. So the n is 2, right? And we just talked about that we're going to go backwards and say, well, the degree minus 1 is equal to the turning point. So if I have the turning point, so instead of minus 1, I can do plus 1, and that will give me a 3. So I know that based on the turning points, this is going to be a third degree polynomial. What is the leading coefficient? Well, as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y also goes to positive infinity. So we remember from our chart that means that the leading coefficient has to be positive. So it has a positive a. And for this situation, we're assuming that the leading coefficient is 1. Okay, so that end behavior based on the odd degree and positive a, we just talked about that as x goes to positive infinity, then f of x goes to negative infinity. And as x goes to positive infinity, as x goes to negative infinity, f of x goes to negative infinity. Okay, so real quick. So just go make sure you review your notes and write that and using that terminology. Okay, what are the roots? So we can see here that we have, it slices through at -2. And so we have one root that's going to be at -2. And then we have another root at 3, but it's a bounce. So that tells us that the multiplicity for here is 2. So for the -2, the multiplicity will be 1. That only occurs once. But the 3, the multiplicity will be 2. And since it's a third degree, that means you can only have 3 roots. You can't have more than 3. That means we can predict that the equation looks like this. It's going to be x plus 2 times x minus 3. And since the minus 3 has a multiplicity of 2, we're going to put a 2 there. Okay, so this is just a quick overview of how you can determine the equation of a graph based on understanding the degree, the leading coefficient, and behavior roots, and multiplicity. All right, thanks, guys.